A brief history of fertilizers. There were many ancient civilizations that used some technique of making the soil more nutritious to improve the growth of plants, such as the Egyptians, who added ashes from burnt weeds. The ancient Greeks and Romans have written that they had discovered a very useful way of adding nutrients to the soil but using animal excretory products. This was the beginning of the agricultural revolution, where farming techniques began to be manipulated and found easier and more efficient uses of farming. In the 1700s, a man by the name of John Glauber discovered that adding saltpeter to the soil would be highly beneficial. Thus Glauber created the first mineral fertilizer. Justus von Liebig contributed greatly to advancing the knowledge that we had of plant nutrition. This led to the understanding of the importance of ammonia, as well as promoting the importance of organic material for plant growth due to its nutritious state. In 1837, a man by the name of John Bennett Laws began to experiment with different types of manure and see how it affected the growth of plants. In 1842, he began experimenting with various materials and treated phosphate with sulfuric acid, and thus forming the first artificial manure. This was the beginning of the artificial manure industry, or chemical fertilizer industry. In 1918, a man by the name of Fritz Haber won a Nobel Prize for his research of synthesizing ammonia that is important for explosives and fertilizer. Okay, so now in the present we have something called the Green Revolution. This began as the world's farming industries began to modernize and new technologies began to spread worldwide. Norman Borlaug, who was known as the father of the Green Revolution, saved over 1 billion people from starvation by development of high-yielding varieties of cereal grain, expansion of irrigation infrastructure, modernization of management techniques, distribution of hybridized seeds, synthetic fertilizers and pesticides to farms.
I will be talking about organic and inorganic fertilizers and the processes that take place to manufacture inorganic fertilizers. Inorganic fertilizers are not found in nature, but are made of things that are found in nature, such as minerals, for example, sulfur rock, phosphorus rock, or potassium chloride. They're also made of gases from the atmosphere or from other industries, such as the petrochem industry or the natural gas industry. These give us carbon dioxide and hydrogen gas. This gives you a brief overview of the raw materials and each plant and process that they go through to form two kinds of fertilizers, the straight nitrogen fertilizer and the NPK compound fertilizer. NPK is an abbreviation for nitrogen, phosphorus and potassium. These are the nutrients required for plant growth. Let's start off with the ammonia plant. In the ammonia plant, nitrogen is bonded to hydrogen gas to form ammonia. This happens under high pressure and low temperature. This is called the Haber process. Ammonia then moves on to the nitric acid plant. The Ostwald process takes place here. Ammonia is bonded to oxygen to form nitrogen monoxide, which then reacts with water and oxygen to form nitric acid. This illustrates an overview of the two processes that I've explained. It starts off with the Haber process with nitrogen and hydrogen gas to form ammonia, which then reacts with oxygen to form nitric acid. Nitric acid can then be reacted with ammonia to form ammonium nitrate. At the bottom of this illustration, you can see the contact process. This involves sulfuric acid being oxidized to form sulfur dioxide and then sulfur trioxide. Sulfur trioxide then reacts with hydrochloric acid to form twice the amount of hydrochloric acid. Hydrochloric acid is then reacted with ammonia to form ammonium sulfate. This is a fertilizer as seen in the grey block below. This is another illustration of all the processes I've explained, as well as on the right hand side all the fertilizers that can be formed from these processes and all the components necessary to form these fertilizers. At the bottom right you can see a fertilizer called urea. Urea is high in nitrogen and can be synthesized, but it is also found in nature in the form of urine. So it is said to be an organic fertilizer as well. Organic fertilizers are found in nature. They are high in nitrogen, phosphorus, and potassium, the nutrients essential for plant growth. Some examples of these fertilizers would be manure, which is animal excrement, predominantly horse excrement and chicken excrement. Manure has a very slow release rate, which means that less manure is needed to be added to the field over time. Another example would be guano, which is also excrement of an animal, but of seabirds and bats. Guano is a direct fertilizer, so it can be applied directly to the plant and not under the soil. It's high in phosphorus as well as nitrogen. Natural minerals can also be seen as organic fertilizers, such as limestone, which is used to regulate the pH level of the soil. Another well-known organic fertilizer would be decomposing matter, or compost as we know it. Decomposing matter contains nitrogen-fixing bacteria. These nitrogen-fixing bacteria release nitrogen gas, and this nitrogen gas can then react with water to form nitrates, which are essential for plant growth.
In this part of the presentation, I'll be speaking about the pros and the cons regarding fertilizers. The most common issue facing synthetic fertilizers is eutrophication and algal blooms. Algal blooms are due to the overuse of synthetic fertilizers which aren't absorbed into the soil of crops. When it rains, the excess fertilizer is carried away by the rain into a nearby water body, such as a lake or a river. In the water body, the already existing algae will use the nutrients from the fertilizer in order to grow and flourish. The algae will take up oxygen existing in the water and will block off sunlight, and may also clog the gills of fish. The overbalance of nitrates and phosphates from the fertilizer in the water will contaminate the water and make it unsafe. This may lead to a condition known as blue baby syndrome. Water contamination is due to nitrates which enter water and not plant roots. Contaminated water may exist for many years before it is noticed. Let's look at an average bag of NPK fertilizer. Starting with phosphorus. Phosphorus is not always easy to absorb, and this may lead to an increased chance of runoff and eutrophication. Phosphorus may also contain impurities and heavy metals. Nitrogen fertilizer can be safe if used properly. There is often too much for plants to absorb, and therefore this leads to eutrophication. Let's look at some of the positives regarding fertilizers. Synthetic fertilizers provide nutrients to plants and therefore allow greater crop yields, as well as helping the crops against weeds and diseases. Synthetic fertilizers are better for a quick response in crop yields as well. Organic fertilizers help to improve the fertility of the soil by feeding microorganisms, as well as reducing soil erosion and hydrating the soil.
The majority of farming takes place with the use of synthetic or inorganic fertilizers. They are produced in ways which are theoretically unable to be continued, as the resources used in their production are almost always non-renewable. Potassium and phosphorus are mined out of the ground and are a finite resource. Even if we were to decrease the amount of phosphorus and potassium used, other elements in the production of synthetic fertilizers, such as oxygen, nitrogen, or carbon dioxide, are created through processes that use a lot of energy. Some estimates show just under 2% of the world's energy production. We are moving into a world where, due to the depletion of fossil reserves, energy is going to become exponentially more expensive, making it much more expensive to produce inorganic fertilizers, pushing up the price of food. Due to this fact, we need to find an alternative, the most obvious being organic fertilizers. Organic fertilizers include naturally occurring organic materials, such as chicken litter, manure, worm castings, compost, seaweed, bone, guano, bone meal, or naturally occurring mineral deposits, such as saltpeter. There are many benefits to organic fertilizers, the biggest being that they are renewable. They share many of the disadvantages with inorganic fertilizers, but can be said to be the lesser of two evils. If we do not change soon, we will end up in a world where our farming produce will not meet the needs of our growing population, and people will have to start moving from cities to a more subsistence-based farming.